of 3D printing news Unpeeled. And today, the big news is that Prusa Research has released a new 3D printer, the MK4. So Prusa, of course, is well, definitely one of the biggest designers of additive manufacturing 3D printers in the world. With its MK3 printer being the basis of most of the desktop 3D printing industry. Now, so the MK4 in and of itself is, of course, a big event. On top of that, the MK4 is a big event because not only because the whole industry derived from it, but Prusa Research itself sells about 350,000 of these things or something like that. So that in and of itself is a big thing. And this is a great release. I think I'm really, really happy with this personally on a personal level. To see what's going on with this printer and to learn from it. It seems like a really, really very, very solid release, and it seems like a really significant release, and it seems like it's a printer made by people who love printing, and so they're doing some stuff that I think is really, really very, very very, very important. So the new MK4, what's there, what's not? First off, I think the highlight thing is here. It's got a 32-bit STM32 main board called a buddy board. It's got dynamic 2130 stepper driver, so it'll be nice and quiet. Maximum nozzle temperature is 300 C, so that makes polyamides very accessible. Max heated bed 120 C as well, so you can print a lot of the main kind of engineering plastics that are now predominating in desktop 3D printing. There's better sensors. There's a magnetic heated bed with PI or all-time spring sheets on it. Better extruder gears, better gear ratio, elimination of slippage, which we know is a desktop 3D printer problem. There's a load cell-based auto leveling approach, which gets you to a better first layer, also makes the whole auto leveling process better. Also, auto leveling and calibration can also be for one part of the print bed alone, which would make that process faster. The chassis is from extruded aluminum, so injection molded aluminum, which apart from just using extruded rails, which other processes or other printers are now doing. So, these extruded window rails essentially are the basis of a ton of these printers. It's very cheap. You can join them in lots of different things. Now, Prusa is now moving to an injection molded aluminum solution, which will help them differentiate from the competition, may even end up with a stiffer printer, may even end up having them use less material. So that's one way they can use their manufacturing prowess. We all know that these guys are great on QA, they're great on quality control, they're great on just overall quality. And they can use this, they can leverage this into having maybe a more cheaper on aggregate chassis, which may even work better than just extruded frame. So that's one way for them to differentiate themselves. We've got a one-click 3D printing version. There's an RGB status bar on the bottom of it. Kind of gimmicky, but you can imagine it'll make you kind of unobtrusively can see the printer work in the background. That could be nice. There's some Clipper inspired stuff going on. We all know that Clipper has been making a lot of headway. Rather than adopt Clipper straight away, they've kind of done a super Clipper inspired rewrite of their own software to incorporate the best features in Clipper. Now, of course, over Marlin Clipper, there's a lot of excitement around Clipper for it being faster. And they say that they've improved a lot of these things, and they've adopted some interesting features. One is Input Shaper. It's kind of a speed control in the motion system. What happens is that you can, for example, slow down stepper motors more gradually in corners, or slow down steppers or other motion control more gradually to reduce artifacts. So that's what they're doing. I think that's a really sensible thing to do. There's a thing called Pressure Advance. This is essentially much better retraction, much better filament speed and extrusion kind of cooperation, if you will. There's also Nextruder quick swap nozzles. It's 2 screws and 2 plugs. Not ideal, but this is really, really important. I think if you have an industrial type printer using this in a business, you don't want to do this atomic method stuff anymore. Come on, you just want to reduce, get the thing out of the way, get rid of the nozzle, get a new one. So that to me is a very, really important feature. I'd like it to be less, I'd like it to be more like the Ultimaker, where it's even easier still. But hey, hell, this is a hell of an improvement before if you really need to get a print done. We could also, quick swap nozzles for different nozzle diameters. I'm not sure if people are going to be doing that, but hell, just get rid of that nozzle block, get printing, and solve the nozzle block separately or tomorrow morning is to me is a huge, really practical advance. It's got 250 by 210 by 220. And there's also MMU3, which is a 5 filament kind of filament mixing kind of station. That's one of these things that, by putting it on this platform, Prusa can make this a much more mainstream solution. Um, yeah, but is it going to be something that people are going to use? We don't know yet. But that is a filament mixing box that could use up to 5 different filaments and print in different colors, which I kind of find marginally interesting. But what I do find interesting is the ability to mix, like for example, flexible like a TPU with a rigid plastic and get like different kind of parts. That to me is much more interesting. All in all, loving this. Loving this. It's 1,099 or something like that. Reasonable price. We all know that the Bamboo Labs printer is making a big, big impact. That's a really fast, really great machine. It's, I think it's going to be a bit limited on the longevity there. I'm not so sure about a lot of part reliability, but damn, that thing's fast and damn, it works really, really well. So Prusa really had to step it up a notch. And I think they did. These are all things that are really practical, really nice. None of this boring feature stuff. It's stuff we want. This is stuff we need, and I almost bought one while doing the research for this thing. I was really close to buying one already, and people give me printers for free to test them and stuff. So, the fact that I'm close to buying one is it's a good sign. I think it's a good sign. I'm a voting party of one, but still, this is something made by people who know their 3D printing, who know their 3D printers, and we all know the quality is good. So generally a good development. Now, how long is it going to take for the clone army to take up this printer and to distribute it? How long is it going to take for them to refine it? What things are they going to take? Or are we going to be seeing a kind of more divergence of the clone army into their own models? That, I think, is a really big industry thing that we need to be looking at. So very exciting, really, really happy with this. The only thing that I think they should have done a little bit more with this is material conditioning, so getting the material on temperature, stopping material kind of from drying out. I would have loved to see some kind of cartridge solution, some kind of more kind of heating, drying kind of solution from these guys, because I think that would be a really valuable product to push out to the market to really improve stuff. But apart from that, super happy with this. Super happy with some of the really practical things, like the VFA. This is another thing we're seeing here. We have special motors that are said to work better to really eliminate artifacts. There's another thing that they really want to do to eliminate resonance in the part. These are parts we know. We have these moire effects in the parts and stuff. We know that these things occur, and they're really looking at a motor level, saying, okay, wait, how can we change the motor in order to reduce this kind of problem we all know we have? And I think that's just wonderful. We don't see other people do stuff like this, and it makes me really, really happy we have these guys. Anyway, okay, next thing. Okay, the next thing is Stratum, which is from the new Raw. So a while back, Dirk van der Kooi, 2000, I don't know, 14 or something like that, he took a robot arm and made furniture out of it. And people have been copying him ever since. The new Raw is a Dutch design studio, and they specialize in, well, really cool designs, I think, usually from recycled polymer. So they're in a really beautiful place. I think it's a really nice play. I think if you're looking for something to do, start a design studio making recycled furniture with using robot arms. I cannot consider anything more fun, and and there's a lot of potential there as well. So Stratum is 18 meters long. It's a statement piece, kind of one of these corporate lobby kind of bam in the middle pieces, and then it helps. Of course, it's made from 350 or 700 kilos of plastic waste. You can imagine this, you imagine this in your city government, the office that you get your passports or your driver's license, or the main county council kind of thing. This is a beautiful thing. Statement piece, like we are innovative, we are recycling, that kind of thing. Beautiful idea of this. This, I think, is made for a company called Picnic, which is kind of grocery delivery service. And it's made partially from the supermarket stacking crates, and you can see that mixed in the gray materials, the supermarket stacking crates, and the other materials, the regular build material. I think it's a beautiful product. I think they could sell this for a lot of money. I think they can make a lot of money on this, and I think it's a fun thing to have. And it's something you wait for 5 minutes. You sit on this thing while you wait for your job, the people to pick you up in the lobby for your job interview. So it'll do a job. It's also like a combined kind of planter, sit down, standing desk, kind of versatile piece of furniture. I think it's really wonderful, really good idea. This, and more people should be doing this. This is right in the money, and I think that's really, really great. So the next item that we have is okay. Well, Okay, so the next thing is a 3D printed scaffold. I don't have an image of that for you, but work from Zui Dong, Xue Dong, and Jason Spector at Cornell. So we're seeing a lot of work on 3D printed scaffolds for breasts, specifically for breasts, right? This is the Whale Cornell Medicine Center, and we're seeing work on 3D printed scaffolds, reabsorbable scaffolds from Bellaseno, Lattice Medical, Heel Shape, Animedi, and now these guys at Cornell. There's some other researchers working on it as well. Now, there's a lot of area here because there's mastectomies is a really large procedure. It's a very invasive, very, very kind of traumatic procedure. By restoring the breast in a more kind of true to original form way, it really can help sufferers considerably. On the back of this, of course, breast cancer is something that 1 in 3 or about women will suffer from at one point in their lives. So the group of procedures here is very high. And on the back of this, on top of that, of course, this reabsorbable breast implant could seed tissue and then disappear, so you don't have a long-term silicone implant in the body. Instead of that, what you would have is actual tissue. So that is also, apart from mastectomies, it's also a huge market for breast augmentation, or actually, what we're now it's breast augmentation, but with this kind of approach of putting a scaffold to see tissue, you could also see breast shaping or kind of a surgery. So it's not much per se about the augmentation, but what one could do is to change the shape to be a shape that's more desired or wanted at stage as well, which isn't being talked about, but I think could be have a lot of potential. Now, anyway, what these guys are doing at Cornell is something that I have not heard of before. What they're doing is they're trying to customize the breast to make more and make it more like what people want, right? But they're focusing on the nipples, and one of the problems apparently is if the nipples tend to get reduced in size and reduced in their prominence, if you will, and then they will look very different from the other breasts and very different from the breast as it was previously. So what they're trying to do is make this scaffold out of a material called poly-4-hydrobutyric. I have no idea how to say this. P4HB. Which is kind of a polyester type material, and they're trying to make it out of that material, and so that it is a more natural way of absorbing this thing, and more natural way of creating the breast, and ending up with a better, more true to form or true to the desired effect kind of breast. So I think that's really, really very positive. They hope to engender wound healing and to get an inflammatory response that is good. And appropriate at the same time. So I think this is really worthwhile work as well. So my name is Joris Spiels. This was another edition of 3D Printing News Unpeeled. I hope you have a wonderful day, and I hope you found this valuable.